For question 4, we're going to be looking over the deformed belemnites. So we're going to be measuring the strain length and the original length to determine our elongation. This is our quadratic equation, or quadratic elongation for both of the fossils. Then we're going to use the angle between the belemnites and the stretching lineation to construct a Mohr circle. And then we're going to determine the values for the principal strains. So in order to determine our elongation, we've got our S equals our final length minus or divided by our original length. We can take our measuring tool here and measure from this point to this point. So that is going to be, L is going to be 5.6 centimeters. L naught is just the addition of all of these smaller segments. So we've got 0.7 plus 0.7 plus 0.6 plus 0.7 plus 0.6 plus 0.7. When we enter that all together, gives us 4. So L divided by L naught is equal to 1.4. This is for what we're defining as our 1. This one is going to be our 2. To find our lambda, we take S squared, so it's 1.4 squared, which is going to be 1.96, and then to find our lambda prime, that is going to be 1 over lambda, and that is 0.51. And actually I'm going to determine these as A and B. A and B, so I don't confuse you later. So this is A. Alright, then S for B. Right, we measure the stretched direction, which is about 3.2 centimeters. That equals L. L naught is 0.8 plus 0.6 plus 0.6 plus 0.7. And you add that together, that's 2.7 centimeters. So S, L over L naught is equal to 1.19. So our lambda is equal to 1.19 squared, which is 1.4, and our lambda prime for B is 1 over 1.4, which is 0.71. All right, so these are the numbers that we're going to be using for our Mohr circle here in a minute. The next thing we need to figure out is the angle between the belemnites and the stretching lineation. So here we've defined this as the stretching lineation. These are the angles of the belemnites. So we figure out the point we're lining our protractor up with the stretching lineation and counting over, and we get about 33 degrees. So the angle of A is 33 degrees. Over here we do the same thing for B. We're going to line this up with the stretching lineation, count along here, and we get about 65 degrees. And we'll be using this to construct our Mohr circle. So here we know these are our lambda B and lambda A primes, so we're going to be plotting it on this side of our diagram. So we've got 0.51, which is about right here, and 0.71, which is about right here. Now ultimately what we're doing is we're trying to figure out the actual Moore circle for strain. So if we look at this diagram from our book, right, so this is figure 4.13 from our book. We have now figured out this point on the Moore circle, right? We just figured out what our lambda prime for A and B is. So we figured out this, and we just measured our angle here, right? So we measured the angle from the stretching lineation to the Bell Knights, and then we have to multiply it by 2. So we go this way, right? Remember, we go clockwise when we're determining strain, and we're going to do it for both of our Bell Knights to construct our complete circle. All right, so the best way I found to do this is you draw a line up here and a line over here. Somehow we're going to find a circle that intersects wherever the angles go here, and we know that this first angle, 33, when we double that it's going to be 66, so that's a fairly steep angle. If we go 65 and double that, it's about 130. So that's going to be a fairly shallow angle. So the middle point here is actually not going to be right in the middle. It's kind of be a little bit over. So we're kind of eyeballing this just a little bit, but here we go up to our 66 degrees, and we draw in our line. And then again, we're going 130 because it's double 165. And we draw in the angle here. Now this is going to be how we complete our circle. So now we take our compass and we figure out the radius that connects both of these points. It's a very poor radius, very poor drawing of a circle, but you can see here that this is now our new circle. So our lambda 3 prime, which is one of our principal strains, is going to be about 0.8, and lambda 1 is going to be about 0.4. Lambda prime 1 is going to be about 0.4. Then you can bring it further out into our gamma, right? So this is going to be about gamma prime 1 is going to be about 0.9, and then gamma prime 2 is going to be about 0.15, yeah, about 0.15. So that is how you determine your principal strains using the Moore circle, figuring out our angles for question number 4.